Okay, so did you plugging in 0, 1, 2, 3, and 4 get these values? Yes. Okay, so let's graph these. On our x-axis, what do we want to go by? Ones would be okay. On our y-axis, what do we want to go by? 5, 10. 4s, would 4 be enough? What are we thinking? We could go by 4s. No? Yeah, let's do 4s. Because we would have to get to 46. 46 divided by 4 would be 20. Let's go by 5s. Sorry. All right, so plot the points 0, 30, 134, 238, 342, and 446. Okay, so you plotted those points, and now you're figuring the change in the x values and the change in the y values, and then you're going to put them out to the side. And we're going to come back to those here in a little bit, okay? So on the second graph, you're going to graph the equation y equals x squared using the same values that we did in the above graph. So find the y coordinates and then plot those points, and it looks like we could probably go by 2s, I'm thinking, on the y. Yeah. So x will go by 1s, bless you, and y's will go by 2s. Okay, so fill out that, fill that out and graph your points, and then we'll talk about that. And also find the change between each of your y's. Go ahead and do that. First graph, we filled out the t-chart. I asked you to find the difference or the change for each of the x values and each of the y values. So, did you come up with 1 and 4? Okay. And when you graphed it, some of you said, could we connect them? And I said, you don't need to. But if you did connect them, what kind of shape would you get? A line, right? So this would give us something. Whoa, I didn't mean to do that. Supposed to draw. Where are we? 0, 30. So that would be 5, 10, 15, 20, 25. There we go. So we could draw a line. It would go through that. All right, so the difference on our x's is uniform. It is 1 every time. And when it's that way, we have the same change in our y each time. And notice where we see that number 4 in our equation. Right there. Right there. Okay? So, same change in x, same change in y, and that change is noted in our equation. Let's go down to the other graph, and let's look at that, the difference there. In this one, in this graph, we do have the same change in our x, correct? It's 1. But what's happening with y? Is this a constant change? Constant meaning the same change each time. There's a pattern, right? You could figure out what the next value is. What's the pattern going to be? What do we need to add next to get the next number? 1, 3, 5, 7. Add 9 to get to the next number, so that would be 25. So there's a pattern, but it's not uniform in terms of we're not adding the same number each time. And when you graph this, what kind of shape? Is it going to be a line? No, it's more of a curve, so it goes that way, which in this case would be, if we filled it in and we went to the negative values, we would get a parabola. Okay, so what we have discovered is what is called a linear function. So this one right here is a linear function. So I want you to write that somewhere. You could write it on here. We could write linear function. And it's linear because of two things. There is a constant change in our x. It's the same change each time. And that gives us the same change on our y values. And when we graph them, if we connected all the points, the graph would be in the shape of a line. So that is what a linear function is. And the constant, this right here, is part of our equation. If we solve for y, that's the constant. Okay? All right, so let's look at a couple of other equations here. Today's date up there, we're going to talk about more about linear functions. And so we want to see if we can tell from an equation if we have a linear function or not. Sometimes that's difficult for me, but I'm going to give you some hints and then other strategies you can use if those hints don't work, if you still don't understand it. So on the first one, it's done for you. So it's linear. If we were to solve for y on this equation, what would I need to do to solve for y? Get y by itself, Tawny. What do I need to do?
On the first one?
On number one.
Subtract x.
Subtract x. So we would get the equation y equals negative x plus 10. And does this equation look similar to the one that we graphed, the first one we graphed? Yeah, it does. We've got y, we've got x to the first, and we've got some number outside. So it's going to be linear because y equals x to the first, something x to the first. If it's x to the first, it's a linear function. And we could do the x and y coordinate and show that we've got a change. On number two, we can't have x or y in the denominator and have it be a linear function. So it would not be a linear function. So let me show you out here why it would not be a linear function. And if you want to write these out there, you can. So this is number 2, 0, 1, 2. If I plug in 0, let me go 3 here. If I plug in 0, can I take 2 divided by 0? No, that's undefined. I'm not going to have a value. It's undefined. When I put 1 in for x on number 2, 2 divided by 1 is 2. When I put 2 in for x on number 2, 2 divided by 2 is 1. When I put 3 in for x, 2 divided by 3 is 2/3, or about 0.7. Okay, so remember, linear functions have to have, this has to be uniform. So is the change there the same for each one of those as we go up? Yeah, it's 1. What's happening here, though, is that the same change. 2 to 1 is -1, right? We're going down 1. And then from 1 to 0.7, we're going down how much? About 0.3. So is this uniform right here? No. So this is not a linear function. Okay? X has to be changing the same, and if that is the case, y then has to be changing the same. Let's take a look at number 3. See if you can figure out on number 3 if you think that is a linear function or not. Raise your hand if you think it's linear. Raise your hand if you think it's not linear. All right, so let's find out. I don't know. I kind of I struggle with the equation, so I'm going to try to do the t-chart here to see about that. So I'm going to let x equal 0. When I plug in 0 for x, I get 0 squared minus 0, which is 0. When x is 1, 1 squared minus 1 is 0. When x is 2, 2 squared would be 4. 4 minus 2 is 2. When x is 3, 3 squared is 9. 9 minus 3 is 6. So while I went up by 1s here, all the time, just so I would be able to tell with this, am I going up the same amount with each one of those? No. Not increasing any here, 2 and then 6. So this is not a linear function. This would be a graph of a parabola again. Okay, so talk about the constant. So when we did our graph, remember our constant was whatever it was increasing here over on the right, and that was 4 on our first one, problem number 1 that we graphed together. And so it was in the equation 4x plus something. I can't remember what it was, 30. Okay, so if it's linear, the constant change is going to be the number in front of x. So on number 4, the constant is 8. If we were to do a t-chart and go by 1, 2, 3, 4, each change in the y would be 8 units. Okay. So on number 5, what is our constant of change? 3. It's going to be 3. We have to get y solved or isolated by itself. The constant is going to be 3. On number 6, we have to do some work before we can identify the constant. We have to get y by itself. So what does that involve? I've got this 5x equals 11 minus y. How can I get y by itself? Because I can't just say the constant's 5 yet. Notice how this equation, y was equal, isolated, that equation, y was isolated, and then we could identify what the constant of change was. We can't do that yet on this equation. So, suggestions, Nolan, what do I need to do to get y by itself on this equation? Well, I'm wanting to get this by itself. So what's on the same side with that y? 11. So how can I get rid of the 11? Subtract it, because if I added 11, I'd get 22 on this side. So I need to subtract 11 from both sides. That's going to give me a negative y, and I have 5x minus 11 on the left. Notice these both were solved for a positive y, not a negative y. So how do I make that a positive y? So who said what? Divide everything by a negative 1. So if I'm going to divide this by a negative 1, I have to take everything on the other side divided by a negative 1. And that gives me a negative 5x. Negative divided by a negative on the second would be plus 11. So the constant is going to be what? Negative 5 in this case, whatever's in front of x.